Intro to logical connectives. Logical connectives is a symbol which is used to connect two or more prepositional or predicate logics in such a manner that resultant logic depends only on the input logics and the meaning of the connectives used.
Assalamualaikum warahmatullahi wabarakatuh. My name is Aidil Ubadillah bin Muhammad Hisham. My student ID is 2020617724. Today I want to present about content of logical connective and truth table. Firstly is content logical connective or logical operator. Logical connective have 5 operator. Firstly, conjunction. The statement of conjunction is and while the symbol like intersect. Second, disjunction. The statement of disjunction is or. The symbol look like union. Third, negation. The statement of negation is not and the symbol is negate. Next, conditional. The statement is if then and the symbol is single error. Conditional start from assumption or hypothesis and the result to conclusion. Last but not least, biconditional. The statement is if and only if. The symbol is double arrow and biconditional start with hypothesis to conclusion or conclusion to hypothesis. The second contents is truth table. The first logical connective is negation. We use the variable P and Q is an example to explain the logical connective. The statement of negation is negation P is the opposite of the P. It means if P is true, then negation P will be false and vice versa. Second, disjunction. The statement of disjunction is if either P or Q are true or both P and Q are true, then P disjunction Q are true. Otherwise, P disjunction Q are false. Third, conjunction. The statement of conjunction is if P is true and Q is true, then P conjunction Q is true. Otherwise, P conjunction Q is false. Next, conditional. The statement of conditional is if P is true, then Q is false, then P conditional Q is false. Otherwise, P conditional Q is false. Last but not least, biconditional. The statement of biconditional is if P and Q is true or P and Q is false, then the true value is true. Otherwise, P biconditional Q will be false.
Example. Write each symbolic statement in words. Let P, the sun is shining. Q, we go to Six Flags. R, we ride roller coasters. Question A. P disjunction Q, conjunction negation R. The answer is the sun is shining, or we go to Six Flags, and we do not ride roller coasters. B. Negation P, conditional Q disjunction R. The answer is if the sun is not shining, then we go to Six Flags and we ride roller coasters. Question C. Q biconditional P, conjunction R. And the answer is we go to Six Flags if and only if the sun is shining and we ride roller coasters.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Nina Nabila Rusaina binti Amran and I will continue with the example. Make the truth tables for the following statement. P disjunction negation Q. So for the solution, step 1, determine the number of rows required. Since the statement contains 2 basic variables, the truth table will require 4 rows because 2 squared equal to 4. The next step is determine the number of columns required. There will be 1 column for each basic variable and 1 column for each occurrence of a logical connective. In the statement P disjunction negation Q, this means that we will have a total of 4 columns. The next step is begin filling in the columns. The first 2 columns represent the basic variables P and Q. We label them accordingly and fill them in such a way that each row takes into account a different combination of truth values for these basic variables. The configuration shown below is standard. So the next step is label the remaining columns, bearing in mind which simpler components are required in order to construct the statement P disjunction negation Q. In order to construct the statement P disjunction negation Q, we need a column for P and a column for negation Q. The truth table already has a column for P and a column for Q, so we now label the next column with a negation Q. We fill in the column by referring to the values in the column for Q. Every entry in the column negation Q will be the opposite of the corresponding entry in the column for Q. So if in the column of Q is true, false, so the negation Q will be false, true, false, true. Now that we have a column for P as well as a column for negation Q, we can combine them to construct a column for P disjunction negation Q. We fill in this column by referring to the columns for P and for negation Q, and bearing in mind the behavior of the odd connective. P disjunction negation Q will be true in any row where the column for P is true, or the column for negation Q is true, or both P disjunction negation Q will be false in a row where the P and negation Q are both false. As you can see, these are the complete truth table shows the behavior of the statement in every conceivable situation. As we will see later, it can be used to compare the statement P disjunction negation Q with other compound statements, and to identify other different looking statements that are equivalent to P disjunction negation Q. So the P disjunction negation Q will be true, false, true. That's all from me. Thank you.
Next, in logical connective, some proposition may contain all true value of their variable as true only, or false only, or both true and false. So first is tautology. A proposition P is a tautology if it is true under all circumstances. It means it contains the only T in the final column of its truth table. So let's look at P implies to Q. When P is true and Q is false, then the statement in P implies to Q will become false. Otherwise, when P is false and Q is true, then the statement in P implies to Q will become true. Next, we look at the column Q implies to P. So when P is true and Q is false, then the statement Q implies to P will become true. Otherwise, when P is false and Q is true, then the statement in Q implies to P will become false. For the final column, when P implies to Q or Q implies to P, it will become all true because it will choose either one for true. So the final column will become true, only true in the column. Next is contradiction. Contradiction is a statement that is always false in the final column. So in P implies to Q, it will become true, false, true, true. And negation of P implies to Q will become false, true, false, false. Because when P is true, then negation of P is false. So the statement must be opposite with P implies to Q. So it will become false, true, false, false. For the final column, Q and negation of P implies to Q, the answer must be true for both statements. So there is no the true value for both statements. So in the final column, it will become false for all the statements. For the last is contingency. Contingency is a statement that can be either true or false depending on the true values of its variables. So when P implies to Q, it will become true, false, true, true. And statement P and Q, it will become true, false, 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 because both statement P and Q must be true. So when P is true and Q is false, then statement P and Q will become false. Otherwise, when P is true and Q is true, then the statement P and Q will become true. For the final column, P implies to Q implies to P and Q. Uh, the answer is true, true, false, false. Because when P implies to Q is true and P and Q is false, then the statement P implies to Q implies to P and Q, it will become false. Otherwise, when P implies to Q is true, P and Q is true, then the statement P implies to Q implies to P and Q, it will become true.
The conclusion that we can get in this subtopic is we learn about types of logical connectives and symbols. Examples of logical connectives are conjunction, disconjunction, negation, conditional, and biconditional. Next, truth tables. To make truth table, we need to use all types of logical connectives and symbols. Last, tautology, contradiction, and contingency. To use these three, we need to know about a proposition, and in a proposition, we need to know about all the true value first. If all the true value is true, then we use tautology. If all the true value are false, we use contradiction. And if all the true value are true and false, we use contingency.